here. But welcome to our 3:30 after school STEM show. I am Ryan, one of the educators here at the Science Center. And I have, of course, in front of me a bunch of critters, and we're going to talk about these in just a second. But before I do, a couple things. As far as our opening hours, currently we're open Friday, Saturday, Sunday, and Monday. So the Friday, Saturday, and Monday we are open 9:30 to 5, and the Sunday we're open 1 to 5 here at the Headwaters Science Center. But starting June 4th, so that's the first Friday in June, we're going to open up that day like we would normally. Like I said, we've been open Fridays for the last several months. And then after that Friday, we're going to be open 7 days a week, all the way up until Labor Day. So remember, starting early in June, starting June 4th, we're going to be opening up 7 days a week. And it's going to be 9:30 to 5 every day except Sunday. We're going to keep that 1 to 5. So open right after lunch on Sunday. Also, big thank you to the Beltrami Electric Co-op. They gave us a very generous donation to underwrite these, so big thank you to them. And now, with no further ado, I think we're going to get into our show here. I left my markers on the cart over here, so I'm going to snag these quick. And like I said, I have a bunch of animals and kind of animal parts, I guess, here with me that we're going to talk a little bit about. And specifically, the topic I want to talk about today is sort of how we sort animals, how we say this animal is a part of this group versus this animal is a part of this group. It's something I've talked about in a number of these shows. It's something I really like talking about. It's something that if you come and visit us and, come talk to me on the exhibit floor, I'll probably talk to you about a little bit. And specifically, I want to talk about how scientists have done this kind of over history. So, big important thing happens in 1860, whatever, where Charles Darwin writes this book, this very formative book for the field of biology called On the Origin of Species by Means of Natural Selection. And starting at about that time, and shortly thereafter, there's, as science tends to do, you argue about it for a while, and then eventually you kind of settle in and accept an answer that seemingly works. And so, starting in, that 1860s, 1870s period, is suddenly this big rush where you're trying to say, okay, we are now accepting that all these animals that exist on this planet, all these, not just animals, but things like plants and fungi and all these things are related to one another. Now, how do we say how closely these things are related to one another? How do we determine what's closely related to what? And at the time, because it's the 1800s, the best way they had to do that was to look at two things and say, well, that thing kind of looks like that, so they must be related. And that one kind of looks like that, but a little bit more like that one, so these two must be over here. Maybe this one's a little closer, but over here, and these are over here in a completely separate area. They're relying on what we would call phenotypical traits. And maybe that's a word I'll write on the board. So, phenotype is the word there. And like I said, phenotypes are physical characteristics that a living organism exhibits. Things that you can look at and you can say, okay, part of my phenotype is that I have fingernails. Part of my phenotype is that I have eyes. Not everything out there has eyes. Having eyes makes me distinct from a plant, for example. So, physical traits that are worth noting. And what you end up seeing as kind of very early sorting of things goes, is you end up seeing a lot of diagrams that look an awful lot like this thing I've drawn on the board behind me. And so this is what we would call a kind of very basic, what we call a cladogram. That's another good word. Maybe I'll write that on the board too. Cladogram. Excuse the handwriting. And so what a cladogram is sort of you take a batch of living things and you sort them based on how you think they're related to one another. And so the one I've got here is animals. And so you can see I've got invertebrates, I've got fish, I've got amphibians, birds, reptiles, and mammals over here. And so if you just go onto Google and do a Google image search for cladogram, you're going to see something that looks very similar to this. And you might even see something that looks like this that also has what we would call phenotypical traits listed on it. So you might see where it has a line down here, and in between invertebrates and fish, it would say something like spines. So, like a backbone spine. And what it would then mean is that everything past that line has a spine, everything before that line does not. And then between fish and amphibians, it might say something like 4 limbs. And everything beyond that has 4 limbs, everything before that doesn't. Amphibians and birds, probably like amniote. So it's some stuff about like how their egg birthing process works, basically. Amphibians don't have amniotic sacs. Everything beyond that does. And then between the birds, reptiles, and mammals, it would probably say something like fur and hair. And then up here it would say like scales, and over here it would say feathers, or something along those lines. So you have these dividing lines that are in there that are like one specific physical trait that we say, this is the thing that makes this thing different from everything around it. So it's a methodology that was used for, gosh, probably a century, pretty much as like the main way that we sorted critters, was with stuff like this. And as we get into the mid to late 1900s, things like radiometric dating start coming into it more, and then eventually, like kind of within the last 20 years or so, genetic sequencing has really become the main way that we sort these critters. And so as we've kind of gotten into these more recent methods, the shortcomings of doing things like this have really kind of come into bear here, been made apparent. So, for example, I have in front of me a frog. And so one of these lines that you might put between amphibians and birds, reptiles, mammals, if you don't want to write amniote, because that's a big word that you don't want to have to remember, you might say has claws or nails. Did mention I have fingernails. All the primates have fingernails, everything else has claws, basically. Birds have claws, reptiles have claws, yada, yada, yada. But amphibians, as a general rule, do not have claws. Well, the thing that I have in front of me is, of course, an African clawed frog. How can it be a clawed frog if it doesn't have any claws? If amphibians don't have claws? Well, turns out there's a thing called convergent evolution that exists. And so convergent evolution happens when you have you have a trait that evolves independently in kind of 2 separate lineages. So you see this a lot of times with stuff that is just like generally very useful to have. So you can think of something like fingers, or like grasping things on the end of your limbs. You know, our fingers that we have are not at all closely related to like the claws that a crab has, but we use them in very similar ways. That'd be a good example of a convergent evolution. We've evolved very similar traits because it's just a useful thing to have. Claws are another thing that this particular species of frog has developed after this divide happened. But, like I said, if you were making a diagram like this, you would say, okay, maybe I have to call this a reptile now because it has claws. You wouldn't actually do that because there's a million other things that you would potentially use to separate, but you can see where things like this can present an issue for your phenotypical species dividers out there. One that you would probably encounter out on the exhibit floor pretty frequently if you come and visit us, one that we've had here since the very beginning of the Science Center, is the legless lizard. So I have Tristan here with me.
Someone asked in the chat, can I read that?
Yeah, you can read chat. Yeah, you can take them out. And so, like I said, we've had legless lizards here at the Science Center for pretty much as long as we've had a Science Center. So if you've been here at any point in the last 27 years, you've probably seen one of these. And Tristan's been here doing animal handling with us as a volunteer for the last
7 months?
Yeah, more than half a year at this point. And Tristan knows that one of the most common questions you get when you start taking the legless lizard out is, a legless lizard, why isn't that just a snake? So, why is that not just a snake?
Well, there's many different things from these two. One of them, a lot of this guy's internal structure is mostly the bones. Like, it has a skeleton throughout. This guy, on the other hand, his skeleton ends from right here. The rest is just pure tail, nothing there.
And so there is some skeleton in the tail too, but what he's saying is the torso on this one ends, probably about where your pointer finger is right now. And the torso on this one ends about here, and just only has this little bit of tail at the end. There's, big long length of tail there. What else we got?
Another thing that's different is these guys don't rely on hearing at all. These guys with their hands hear everything.
Yep.
They rely on hearing.
Snakes, terrible hearing, don't even have any external ears. These guys do have external ears that you can see. Anything else?
The big thing, these guys have shed scales off their eyes, so they don't need to blink at all. These guys on their hand, able to blink everything.
Yep. Snakes don't have any eyelids. Legless lizards do have eyelids. They can blink. All good things. All correct information you've given me. Like I said, Tristan's been on the floor here. He's listened to the other staff answer this question, because like I said, it's a question we get a ton. He's been listening. Great job, Tristan. None of the information you gave me was actually the answer, though.
What?
So, what we've described, basically, is a bunch of symptoms. So, you've described a bunch of things that are different between the legless lizard and the snake, but ultimately, what the question I was asked is, why is that not a snake?
Because it's just determined as a lizard other than a snake.
Yeah, exactly. And like I said, not trying to dunk on you here. Like I said, this is the exact same answer I generally give on the floor, and just using this as an example of a place where, we even do this very similar type of thing at the Science Center, where somebody asks us a question, and you kind of read into the question okay, they're not really asking why are they different, they're asking how are they different, and we give them an answer based on what we assume the question is. And like I said, I give that same answer all the time to that same question. Like I said, not trying to dunk on you here. But ultimately, what we are describing when we say stuff like that are more symptoms. You could say the same thing I could say, I have the flu, and you could say, well, why do you have the flu? And say, well, I'm coughing, I'm sneezing, I have a headache, I have a fever. Those are all true. Those are all symptoms of having the flu. None of those things are why I have the flu. I have the flu because I have the flu virus in me. And so, just like that, all those things you described, the eyelids, the ears, the different shaped skeleton, are all symptoms of these things being different, but not why they're different. And so, I think it'd be worthwhile to talk about some of these other methods that we use to determine how differently or closely related things are. And so, like I said, we talked about a bunch of different phenotypes there, but externally those things look very similar to someone who's coming in and just looking at it. You would assume they're very closely related, even if they're not really. So, thank you, Tristan. Thanks for lobbing me up there and let me put that away on you. And so, another way, kind of a little bit more recent way, but not necessarily the most current, most recent way that we tend to do these things, is with what we would call recent common ancestor. And so, measuring things as being closely related by how recently their most recent common ancestor is something we've been doing for, again, decades and decades and decades at this point. And it's kind of the way that was kind of the most popular way of doing it, when I was in school. When I was coming into high school and, starting to take some of these courses in college, it was a lot of most recent common ancestor stuff we were talking about. And so with that, what you would say is rather than doing... Rather than having a big cladogram that is like this, and in between here, you're putting phenotypical traits, instead what you would say is, okay, invertebrates and fish, that line diverged from one another 500 million years ago. Fish and amphibians, that line broke apart maybe 200 million years ago. Amphibians and reptiles, that's more than 200, that's 300. This is probably about 200, and this is maybe 100, yada yada yada. And so we would say, because these divides happen more recently, that, these two are more closely related to each other than they are to the amphibian, because their most recent common ancestor is more recent. There are fewer generations between a snake and a legless lizard than there are between a snake and a gorilla. So the snake is more closely related to the lizard than it is to the gorilla. Here's the thing with that, though, is not everything changes necessarily phenotypically at the same rate. Have any of you guys out there ever heard of a coelacanth? Any of our 2 audience members here ever heard of a coelacanth? Great. So, a coelacanth is a animal that was thought to be extinct for the better part of like 60 or so million years, but was discovered in like the early 1900s sometime down in South Africa. Somebody found one for the first time, and like I said, it was a species that had been assumed to be extinct for 60 million years or so. And humans and coelacanths, that divide happened about 400 million years ago. Long time ago in terms of animal lineages, about 400 million years ago, like I said. Whereas the coelacanth versus like fish divide happened about 450 million years ago. So, because our most recent common ancestor with the coelacanth is only 400 million years ago, and a lamprey or a trout or whatever's most recent common ancestor with the coelacanth is about 450 million years ago, we would say in a most recent common ancestor model that humans are more closely related to coelacanths than coelacanths are to fish. Here's the thing though, coelacanths live underwater, have scales, have fins, have gills, lay eggs. They do basically everything that you would expect a fish to do. Yeah, what's up?
We have a question. What class is this supposed to be teaching?
What class is this supposed to be teaching? Interesting question. I would say this is mostly a biology class. This is kind of like probably like early college level, late high school level type of biology topic. This is something that like I said, learned about probably initially in high school and didn't go like deep into until college probably, where we're talking about kind of deeper level sorting of different species. But so if we look at a coelacanth, you look at it and obviously be like, oh, that's a fish. But like I said, because coelacanths are what we would call lobe-finned fishes rather than ray-finned fishes, within a most recent common ancestor model, we would say that humans are actually more related to them than modern fish are. Which you look at that and you're like, yeah, that's definitely not true. And so that's where genome sequencing comes in. And like I said, genome sequencing is something that's very new. It's something that has only been around like at all for probably 30 years and has only been something that like can be done pretty readily within the last probably 15. And so there's still a lot of it that needs to be done with a lot of different species out there. But like I said, as we are doing it more and more, we're able to look at it and say, okay, our DNA is more similar to this thing's DNA than it is to this thing's DNA. And what we find is that a lot of what we were doing was pretty accurate. You know, there's definite tendencies with how similar things look, different traits that they have, or how recently they are related and how similar their DNA are to one another. But we are finding areas too where that's not necessarily holding to be true. And so it's been a really interesting thing over the last like 20 years. Like I said, this is mostly stuff that's happened like since I was in college, so it's always something that's fun for me personally to go back to and like look at and be like, ooh, that's different. Turtles are in a whole new spot in the lineage than where they were 15 years ago. So it's fun stuff for if you're like me. But so I think I want to go through now and just look at a couple other examples of things where we have things like the legless lizard versus snake relationship where, you know, we sort of identify a group based on some specific trait, but like I said, they're not grouped into that thing because of that trait. Having that trait is symptomatic of their being in that group. So snakes are a great place to start. And this is good information for my 2 volunteers I have with me who take these things out. If people want to know really like what the definitive like phenotypic trait is that makes a snake, how we historically have said, yep, this thing belongs in the snakes rather than in the lizards. It's got nothing to do with legs. It's got nothing to do with tail length. It's got nothing to do with the eyelids. It's all the jawbone. So snakes have a really unique jaw structure to them. And as I said, for the last, most of history, that's how we've said what a snake is having this really goofy jaw that we don't really see in anything else. It's something that's unique, so we group them together based on that. Primates. Got 2 skulls with me here. One of these is a human skull. This is this is Neanderthal skull. Human, depending on who you ask, I suppose. But works for this purposes anyway, because it's still a primate. Key traits of primates: fingernails. Nothing else has fingernails. The flat nail rather than the claw is a signature primate trait. But the key thing with at least the apes, I guess I don't know if this stretches out to all primates, but at least the great apes, is their dental formula. So you can count the teeth on one half of either the upper or lower jaw. And so you would say it has 2 incisors, 1 canine, 2 premolars, and 3 molars. So you would say 2, 1, 2, 3. And you would say, okay, 2, 1, 2, 3, that's the dental formula. You can look at my gorilla here. 2 incisors, 1 canine, 2 premolars, 3 molars, 2, 1, 2, 3 dental formula. We have a bunch of other like ape skulls on a table on the exhibit floor here. You can go into any of those mouths and count them, and you're going to find that exact same dental formula. Again, something that gets used to diagnose whether or not something is a primate, but again, it's not why it is a primate, it is symptomatic of there being a primate. Weird distinction to make, but one that ultimately becomes really important once you kind of get into the academia of this a little bit more. But I've probably been going for a while at this point. What time is it? Yeah, I'm about at my time. So I guess we'll say thank you all for watching. Again, thank you to Beltrami Electric Co-op. If you're interested in visiting and seeing some of this material out on the floor and interacting with it, or interacting with Tristan or Z behind the camera here, you can come and visit us. Like I said, we are open right now, currently 4 days a week, but soon to be 7 days a week here at the Headwaters Science Center in Bemidji, Minnesota. I'm here most days. I'm here full time, so if you want to interact with me personally, it's a spot to find me. Otherwise, thank you for watching, and what do we have tomorrow? I don't know what we have tomorrow. It's actually going to be me tomorrow. I got to figure out what my show is going to be, so we'll see you then. Hopefully it goes well.